All right, let's get into this. We're actually still going to talk about concepts we just finished in similar triangles. So I got a proportion up here. A little reminder. The numbers, variables I plug in for A and D are called the what of the proportion? You got a 50-50 shot. It's extremes. And whatever's in place of B and C are called my means. Right now, what I'm going to do with you is we're going to talk about a special type of proportion called a mean proportion. A mean proportion. And what happens in a mean proportion is the following. Whatever's in place of the means are exactly the same. The same values are in for the means, two different values in for the extremes. That is called a mean proportion. Means are the same, extremes are different. So what I'd like your help in doing here on this first example, can you find the mean proportional between 4 and 16? Here's what I'm asking. 4 and 16 are your extremes. Give me a number that I can multiply by itself that gives me the same product as 4 and 16. Take a look, that's a mean proportional. Extremes are different, means are the same. Means are the same. All right, cross multiply with me. X squared equals 64. And the numbers are going to come back too in big time fashion in a little bit. Take the square root of each side. X is going to be equal to. I thought I had you guys. Paul? Not just 8. Yeah, I agree. 8 works, but so does. Everyone agree? -8 times -8 gives me 64. 4 and 16 give me 64. So plus or minus 8. Be careful there. I do get the plus or minus version. So a mean proportion, means are the same. My extremes are different. Now, as you guys know, usually we deal with diagrams. And I have to reject the negative answer. In that case, I won't ask for the mean proportional. I'll ask what's called the geometric mean instead. That is the positive version of this. The positive version, the geometric mean. So can you find the geometric mean of 15 and 20? 15 and 20, what's the geometric mean? So the same value I multiply by itself, that gives me the same as 15 times 20. So I set up my proportion with 15 and 20 as my extremes. X and X as my means. The means are always the same. All right, we cross multiply. I get X squared equal, what do you got, 300? Let's take the square root of both sides. And again, this unit's going to be heavy algebra. Most of my answers are going to be required to be in simplest radical form. So I'm asking you to break down 300. Let me do that again in case anybody didn't pick up. I'm asking you to break down 300. Find the biggest perfect square that goes into 300. I think I laid it on pretty thick there. Biggest perfect square? 100 times 3. So in simplest radical form, my answer will be usually plus or minus, but I want the geometric mean, the positive version. So yes, 10 radical 3, positive 10 radical 3. So welcome to my new types of proportions, a mean proportion. Means are always the same. Get used to that today. Any questions before we put the geometry part to it? All right. Let's do this. I want to show you a special case scenario with similar triangles. Can everyone do a giant, not that giant, but decent sized right triangle for me? And let's label it ABC, where B is your right angle. So here's the scenario. You start out with a right triangle, and then I'm going to use an old vocabulary term here. I want an altitude drawn from the right angle to the hypotenuse. I want an altitude drawn from the right angle to the hypotenuse. So we'll draw this blue line in here going to AC. Let's call that point on the hypotenuse D. Can you tell me, if you don't remember your vocab, what markings can I put on my diagram if that's an altitude? Right angles, yes. Altitudes form right angles. So I have right angles here and here. So does everyone see my diagram? A right triangle with an altitude drawn to the hypotenuse. How many triangles are in this diagram? Total triangles in the diagram. I should have how many? 3? Okay, so instead of naming it with letters, I'm just going to call this triangle 1, triangle 2, and I'm going to name the big dog triangle 3. Let's see if we learned anything from last unit. Look at triangle 1 and look at triangle 3. Do they have a pair of congruent angles in them? Triangle 1 and triangle 3? Name them. Where are the congruent angles in triangle 1 and triangle 3, the big one? Okay, I'm hearing 2 different, which are correct. They both have right angles, and they both share angle A. What am I trying to tell you about triangle 1 and 3? If they have 2 pairs of angles that are congruent, they are similar. All right, so triangle 1, similar to triangle 3, by angle. The right angles and the reflexive angle A. Next question. Triangle 2 and triangle 3. 2 and 3 here. Do you see any congruent angles there? What are the congruent angles in those 2? Jonah, 1 pair?
C and C.
C congruent to itself, and they both also have right angles. So what do I know about 2 and 3? They're also similar. Now that you know that 1 and 2 are similar to 3, anybody want another conclusion? 1 and 2 are both similar to triangle 3, so Serena? They are similar to each other. 1 and 2, because they're both similar to 3. What am I trying to get at here? Sum this all up for me. What do you know about all 3 triangles? They're all similar to each other. All 3 are similar. Ooh, we could take this another level now. If all 3 are similar, what do you know about their corresponding sides? They're all proportional. Yeah, CSSTP, right? Corresponding sides are in proportion. Oh, here we go. Here we go. Now I'm going to test somebody's limits right now. Don't write this down when I'm about to write down, please. I want to see if anybody can figure it out. Ready? AD in triangle 1 corresponds to what in triangle 3? Sides match up now, right? Sides match up. So what would AD match up with in my triangle 3, the big one? Ooh. So AD in triangle 1, got that. What would that match up with in triangle 3? What's up, Lauren?
AB.
AB? Yeah. Is it true? AB? Or could it be BC? Or is it definitely AB? Can we agree on one thing? This is tough. Right? This is tough matching up the sides if they actually correspond or not. And are we all I'm asking because that's what I wanted to happen, is that this is tough to match up the sides. Are we all in agreement? It's pretty tough. So here's what I'm going to do for you today. I'm going to help you match up the sides by giving you 2 devices that will help you match up the sides. 2 devices. One of them is called Hills. The other is called SAS. All All right. These two devices will help you match up which side corresponds to the other side in another triangle. Before I describe what hills and SAS means, I want your help labeling my triangle up here with the different parts. So let's go back to your triangle you made for me. What was BD called again? What's BD in this diagram? Altitude. There's only one and it's BD. So there's the altitude. All right. In triangle ABC, what's AC called? We have a name for it. What's AC called in triangle ABC? Hypotenuse. Good. So AC here, this is what we refer to as the hypotenuse. Anybody remember what the other two sides are called? If it's not the hypotenuse, it's called the legs. Yes. So AB would be a leg. BC would be a leg. And the only other two parts I want to look at is when I drew my altitude in, I split the hypotenuse into two segments. They're not congruent, but I'm going to refer to those two as segments. Segment, segment. So let me introduce these two devices that'll help us match up the sides. The first one is called hills, HLLS, and that's exactly how you write your proportion. H over L equals L over S. This will help us match up the sides. We just have to remember, what does each letter mean? And I know it's in the text box, great. H stands for the hypotenuse. And what hypotenuse are we only talking about? The one on the original right triangle. So that would be what side for us on our diagram? Whatever AC is, I put there. All right, let's go to L. L is for leg. We put a leg of the right triangle on there. Doesn't matter which one. Doesn't matter which one. But when we go to the other L, which stands for leg, same leg that you just used down here. Same leg. Same value. Aren't we setting up mean proportionals? That's all we're setting up right now. All right, the legs are equal in hills. The legs are equal in hills. We all good? They have to be, because the means are always going to be the same. And the S for segment. What's the first question that comes to your mind? Paul? Yeah, which segment? There's two of them. You put in the segment, ready? You put in the segment that's next to the leg we're using. So for example, if we were using leg BC in this proportion, if we were using leg BC, which segment would we use? The one next to it or adjacent, DC. Okay, that's what the S in hills stands for. The segment adjacent or next to the leg we're using. All good. And I know showing you right now doesn't mean a darn thing. We're going to get reps, though, and you're going to be very good at this before you leave. This won't work all the time. I won't have enough information to do hills sometimes. So I need something else, and that's your second device, which is SAS. S over A equals A over S. If you ever remembered me showing you side angle side and some of you calling it SAS and me getting fired up, this is why, because there actually is a SAS, and it's not that. What do you think S stands for? Segment. What do you think A stands for? What do you think the other A stands for? Same one? Well, there's only one in the diagram. And we know we got to put, for the means, the same number. Mr. Smith, how are you?
What was AD equal to?
We haven't gotten there yet.
Oh.
We're just using it as, a general
Thing.
We have, no numbers yet. No numbers.
All right.
Got to crawl before you walk.
All right. Okay. All right.
Thank you, though.
AD, should it be like DE or DC?
Yeah, this guy. And the other S? Ready? You know the answer to this. Same segment as I put in or different one? Different. These are mean proportionals. The extremes are always different. Means will always be the same, no matter if you're using Hills or SAS. Questions here on Hills and SAS before we start plugging actual numbers in. Means will always be the same, whether it's X and X or actual numbers. You ready? Let's do this. Oh, geez, I forgot. Don't make me regret this. Good. This Hills and SAS business only works for this diagram. What type of triangle did I give you at the beginning of this? What type of triangle is ABC? A right triangle, and you need to draw a, what did we call BD? Altitude to the hypotenuse. That's it. This is only the type of diagram Hills and SAS can be used in. All right, is a right triangle with an altitude to the hypotenuse, which I have on number 1, don't I? Everyone see right triangle ABC, and everyone see altitude BD. Solve for Y. The difficult part of me giving you Hills and SAS, which one do I use? Right? Let me give you an easy question to ask yourself every time before you start. Is the altitude involved? Is it labeled or do I have to find it? Is it involved at all? No, it's not. And out of the two, which is one that uses altitude? So I'm not using SAS. See what I mean here, guys? If the altitude is not labeled, okay, I can't use SAS. I don't have enough information. So I'm going to have to use Hills here. I don't have enough information for SAS. I'm going to have 2 variables. All right, you ready? Numbers are coming back. First of all, do we remember our numbers? Or do we have to do new numbers? We're good? I'm not going to hear silence when I pick like 3 in a row here. Okay. Because I know they're not on your desk anymore. I ripped those off during break because they were getting a little dirty, disgusting. Who's up? 3? You ready, Eva? I know that's you. The H in Hills stands for what, Eva? Hypotenuse, which is the hypotenuse of the original big right triangle. How long is it in this diagram, Eva? 12. Everyone good? 12. So I know 12 over 21. Are you 21 now? Yeah. Okay, that's all I needed. What's the L stand for? Okay, you have 2 legs in a right triangle. You have AB and you have BC, but Ella, there's only one that we really care about, which is what? Leg. Equals leg means, so they have to be the same, over 14. Oh, here we go, this number. I'm not even going to bother. 17. Hi. Ready? What's the S stand for, Tammy, first? Segment. Now I got 2 of them, though. I got 3 and 9. I want to make sure I pick the one that's adjacent to the leg I plugged in. So what's adjacent to side Y? There you go, guys. That's how I can make my proportion. 12 over Y is the same as Y over 3. Those are the sides that correspond. And now we go a little algebra. Y squared equals 36. And I get it, right? It's plus or minus 6, but you got a diagram. Excuse me, you have a diagram. So it's not minus 6, just positive 6. All good? Questions? All right, go on to the next one now. Right triangle, altitude to the hypotenuse. Is the altitude involved here? Yes. So now I want to use SAS. Couple more people. 4. Hi, Griff. What's the S stand for in SAS, Griff?
Segment.
Okay, you got your choice. Give me one.
12.
Sure, we'll start with 12. over. Eva, back to you. What's A stand for?
Altitude.
What's the altitude in this diagram? X. Altitude, same altitude. There's only one in the diagram, and you know the means are always equal. Other S means, come on, fair strong. 2, hi Matt. What's the other S mean?
The same, or no, the different segment.
Other segment, which would be what?
4.
4, got it. X squared equals 48. Oh, you know what's going to happen, don't you? What's going to happen here? What's going to happen? What am I going to ask? Let me rephrase that. What am I going to ask for? Nobody? Yeah, darn right. You're in honors. Simplest radical form. Let's act like it. I don't need a decimal off your calculator. Biggest perfect square. If anybody's plugging in 4, there's a bigger one than 4. Bigger one than 4. What?
16.
Yes. Yes. I should go over this. I've been meaning to, but there just really hasn't been enough time. You don't have to raise your hand. I know it happens. Some of you don't know when you've hit the biggest one or not, and you might struggle with that, and I get it. So let's say some of you thought it was 4. What's 4 times what? What was that, 12? So how do you know if you've gotten the biggest perfect square or not? Here's the answer. You look at the second radical. See 12? Is there a perfect square that goes into 12? Is there? If you're shaking your head yes, that means you didn't pick the biggest one. See that? If there's a perfect square that goes into the second radical, you got to keep going. You did not find the biggest one. So that's how you figure it out. Now, it was 16, right? Times. Any perfect squares go into 3? So you pick the biggest one. That's how you know. No perfect squares go into the second radical. That's how you know you've landed on the biggest one. So this ends up being 4 square root of 3. All right? Okay, I'm done. You now have 6 problems to do by yourself or in your group. I will give you 5 to 10 minutes right now, and then I'm going to have 6 different people tell me what their proportion and answer were. Different people. 6 different people here. So figure out first, is this a Hills or a SAS? And get after it. You can do it within your group or by yourself. Does not matter. Actually, there are letters here.
Wait. No, that's not right. Yeah.
22. Here we go. Letter A. What's our proportion? Good. And then remember, I don't want to keep reminding you guys every time, but the extremes can be switched. Okay. Every proportion I'm given, the extremes can be switched. That's fine. Yep. And we should have ended up with x equals 9. Good deal. How about letter B now? Letter B. Oh, 1 right up here. Meg?
Wait, am I supposed to answer?
No. I just want the proportion that you set up for letter B.
50 over X.
Okay. You're doing right now H over A. H is the hypotenuse, right? Right? I want to use SAS, so I want to put one of the segments first, not the hypotenuse, which you can get. So what's one of the segments?
10.
10 over altitude
X.
equals altitude over other segment. 40. There you go. And we should have ended up with, now, did everyone see you ended up with x squared equals 400? And did anybody try to break it down and maybe got 104? What do you know about 104? They're both perfect squares. And if that's the case, the original was a perfect square. So 400 was a perfect square. You could just take the square root of it. It's 20. All good? All right, how about C? Guys are doing a nice job. 15, C?
25 over x equals x over 4.
Like it. So we ended up with x equals 10 for C. Keep the train going. 6. D?
6 radical 3. Or
Proportion, Lauren.
portion. Oh, sorry. Let me look for it. 12 over x equals x over 9.
There we go. Was everyone all right breaking down square root of 108? 6 radical 3. Okay, again, use my little trick there. I think 4 went into 108, but the second radical had another perfect square that went into it. E? 4. Griff, what do you got for your proportion?
16 over x equals x over 9.
Good job. And that should have been just 12. And finally, finish this out here. Take us home. 22. F.
144 over x equals x over 25.
Good. And that 2 was a perfect square. 60. 3,600 is a perfect square, which is 60. Any issues here? We're going to do another day of it tomorrow, but it gets increasingly difficult tomorrow. So make sure you know the basics right now. And speaking of right now, why don't you get going on the homework? Okay, which are on the following pages. Don't be surprised if a factoring problem shows up here tonight. Just want to keep you on your toes, see where you are.